Next we have the once or after contact, once these two materials come into contact together. The W marked at the top is the depletion region, and then the depletion region is depletion region contains positive donors because it's where the electrons are flowing out into the material. That's making it a positive. And it'll be later, you'll later see the functions of that in the forward and reverse bias when you apply a voltage. So, sorry about that. After we have the contact, we assume that the working function of the M, as previously stated about the metal, is going to be greater than the working function of N, or working function of the N-type semiconductor. So you see the magnitude size difference. So in contact here, we're assuming that when the two solvers touch, the more energetic electrons in the conductance band of the semiconductor can really readily tunnel into the metal in search for a lower empty energy levels, in search of the lower empty energy levels just above the Fermi energy level of the metal. So that's why you have the contact right here. And then, sorry, can rarely tunnel. And then it accumulates near the metal surface. Thus, like I said before, the contact. And then, but this tunneling leaves behind the depletion region. As previously stated before, contains the positive donors due to electrons leaving. The subscript VO in the right hand corner is the difference between the EVO, my bad, is the difference between the two working functions. Well, computationally, the difference between the two working functions of the metal and the semiconductor, which is subscript EVO, EVO being defined as the contact potential or the built-in potential. And then you also have the working function B, which is the Schottky barrier height, which is the potential energy barrier for electrons moving from the metal to the semiconductor. So that's what this difference is right here. It's all across throughout the whole contact, which typically is greater than EVO, the difference of the two working functions for the metal and the semiconductor. In open conditions, however, the Schottky barrier height will equal EVO, and the number of electrons thermally emitted over the potential barrier.